We're told that we are given the second derivative of the function g, and it's given by this function, g prime of x equals 0.1 x to the fifth minus 0.29 x to the fourth minus 0.694 x cubed plus 1.9136 x squared. Then we're asked, at which values of x on the interval, -3 is less than x, which is less than 4, does the graph of g have a point of inflection, where the concavity changes from concave up to concave down? Now, at first you might be like, that's a crazy function. Are you kidding? I have to find the zeros of that function and solve. No. Here's the magic of it. Questions that have these crazy decimals are almost always going to be calculator questions, which means you just need to know how to plug it into your calculator. But we need to know, what are we looking for? The question says we're given g double prime, and we're asked about when the concavity changes. Where's the point of inflection? Remember, when g double prime changes sign, that's when concavity changes. Concavity changes. And not just that, we want to find specifically where the concavity changes in a specific way, from concave up to concave down. Concave up to concave down means that g double prime changes from positive to negative. And how in the world are we going to figure that out? We are going to plug it into our calculator and graph it to see. All right, so here we are. Here's our calculator, and enter. We're going to hit y equals. When we hit y equals, you'll see here we need to enter in our function, and so you're just going to type in the function. I'm going to do it quickly, 0.1 x to the power of 5. And be careful when you do this, when you do the power of 5, make sure you hit to the right so that moves out of the exponent. That's a negative sign. Minus 0.29 x to the power of 4, again move to the right, minus 0.694 x to the power of 3 plus, I didn't move out of there, so I'm going to go back, delete that, hit to the right, plus 1.9136 x to the power of 2. All right, so now we have our equation. This is our our second derivative. And so I want to see, well, first off, let me check my window. We're told in the question, you can see over here, that the interval for x is from -3 to 4. So I want to change my x min and x max to be those values. My x min will be -3, and my x max will be 4. And that'll make my window exactly where I want it to be. So let's go to the graph. All right, now our calculator is graphing our second derivative, and we need to figure out when is the second derivative changing sign from positive to negative, because that's going to tell us where the concavity of the graph changes. What's nice too is that this is a multiple choice question, so you have 4 different options that you can use to check really quickly where certain things are happening. In one location that I see it going from positive to negative is over here. I see that it starts off above the x-axis and goes below. That to me is it's about 2 point something, right? So I know that 2 point something, a little less than 2.5 has to be true. So I look through my options. B can't be right because none of those are 2 point something. And then I see C and D also include -2.6. At -2.6, which is right here on the left, I see that it does change, but it changes from negative to positive. That means that the original function f changes from concave down to concave up. But that's not what we're trying to find. We're just trying to find when it changes from concave up to concave down, which means from positive to negative. It seems that only happens in one location, and we already ruled out those 2 possibilities. Actually, all of these, because -2.6 is wrong for all of them. And so our answer has to be A. It only happens when x equals 2.3.